Hello again. Today I'm going to switch from stacks to queues. Now, a queue, the best way to think of a queue is that a queue is a waiting line. And in most waiting lines, we want the first person in to be the first person out. So this is a FIFO structure. The first person in the queue is the first one out. A stack was a FILO instruction. The first in was the last out. So this catches much better the way we would have a waiting line. And there are many parts of computer science where we need to represent a waiting line, especially in operating systems. And we'll look at that in one of your homeworks. Now, as before, at the ADT level, a queue needs, this time we're going to change the name a little. We're going to call, pardon me, I got the wrong place. I'll just do it this way. It needs a isEmpty function. We had that, remember, for the other case. It needs an isFull function. As with the stack, if we were to use a linked list, we probably wouldn't need this function. But if we use some form of an array, we're going to need this particular function. We also have two functions that I like pop and queue and push. We have an enqueue x, which puts x at the rear of the queue. Remember that with push in stacks, we put it at the front of the queue. Here it goes to the rear of the queue. We have a dequeue x, and this is a little bit different than in the stack. It removes the front item and returns it. We don't separate the two as we did in the stack. It just isn't necessary. Most of the times, this is the what you need. As we said a minute ago, there's no top. There's no equivalent of the top. dequeue does both for us. It removes and it essentially pops the queue and brings us back the value. Now, now that we've got the ADT, how are we going to implement it? We can implement with linked list or queues or arrays. But we have a problem with the array. Our first idea would be to have an array, say X, so that That's just the name we need for it. And let x0 be the top of the array, the front of the array. So if we want an example of this, let's see, I think I can insert. I'm going to insert a small little table here. This is x. And we will enqueue B. I should make it A, it's easier. So we'll put A right here, and this we will view as the front of the queue. And we need to know what the rear of the queue is going to be, so usually we put the rear at the same place. Now, if we enqueue A and after that B, then this would become B, and now this is no longer the rear. The rear would move over to here. Well, so far so good. But now there's a little problem. Now my plan, I have to move this. Now, we go back to home. I have to go to here, I believe, and move back. No, that's it. So now let's dequeue A. Let's see what happens if we dequeue A. Well, I'll copy this again and show you what I think should happen. We have the same thing we had a minute ago. A is gone. But remember, we said that the first element should always, the front should always be in 0. So we'd have to put B here. And now we would have front and rear together here. The problem is we have to move the entire queue every time we dequeue. That seems awfully inefficient, especially if the queue were long. So does that say we can't do this using an array? No, it says if we're going to use an array to implement this, we need to be more clever. And instead of a simple array, we will view the array as a circle. It's not, you've done things like this before in different algorithms. It's not surprising to you, I think. So, in our case here, the rear, if rear is 4, then rear plus 1 mod 5 is 0. So 1 greater than the rear, if rear is 4, goes around the circle. Now that's the method we really need. That works better than most methods. I'm going to do an example of that right now. So let's see if I can get an example going here. Using the circular array implementation. So I'm going to start with an empty array, pardon me. So there's a problem here. Before I want to talk, I do the actual example, I've got to look at a problem. Again, we'll have our 5 elements set up here. And we'll try to figure out how we should declare this as being empty. But the usual way people make this an empty array is they make front at 0 and rear is put as 4. Now that may seem strange. Why is rear 4? Because another way of looking at rear is 1 before the place where we're going to put something. So rear is 1 less than where we will enqueue the next item. So the next item is going to go into front, and that's 1 less. So that's where we're going to put it. Now, let's see what kind of a problem that could possibly add. It doesn't seems reasonable. What's the problem? Well, problem is the following. Take the queue again. And now add A, B, C, D, and E. Now we get A, B, C, D, and E. The front is still at is 0. We haven't taken anything out. But now the rear is 4. It's 1 less than where we would put the next element. And the place we put the next element is at A, at the front. I mean, 1 past the rear. The problem is, this is a full queue. Should be a full queue. But we have rear plus 1 mod 5 equals front. That was the same condition we wanted here. So is 0, which is unfortunately up here the same condition. pardon me, I had the empty queue somewhere. I had it right here. I had it earlier than that, I guess. Yes, right there. They're the same condition. That's a problem. How are we going to tell if it's empty or full? The solution to this is simple, or at least can be simple. Now I can't get my cursor to work. Now this is interesting. My cursor doesn't want to work. Haven't had this happen in a while. Let me escape here and see if that helps. All right, that did help. The solution is to always have at least one blank place. So if we look at what we had here, just copy it down here, then when we come to E, we have the rear is 3. We look at this as a full queue. This is a full queue. So the difference would be now if we tried to put a new element in, if we test rear and front, rear has to be 2 behind the front at least. It can't be 1 behind the front. Where this really comes in is if you're trying to put something in, you look at rear plus 1. If rear plus 1 mod 5 equals the front, then you've got a problem. You're not going to, pardon me, if rear plus 1 mod the front, mod 5 equals the front minus 1, you got a problem. So that is the theory behind a queue. It's really not that difficult. It's the circular array method is a very good way of implementing it. What I'm going to do is I have a handout on this that I'm going to put out in a few minutes, and I'm going to post this video. Then shortly after that, I'm going to give you a new homework involving this material. So I'll see you in a while.